Hi, in this video we're going to be talking about implicit differentiation. So these are functions that are not clearly stated. An implicit function is a function which is not written explicitly as a function of x, meaning that the y is not by itself. It's kind of mixed in with the x's. So this is an implicit function down here. To do implicit differentiation, you need to find the derivative normally, but when you encounter a y, you treat it as a y prime or a dy dx. So we've got this function we want to show that its derivative is this using implicit differentiation. Lost my pen for a sec. So when we take the derivative of that y squared to start off this derivative, we do our regular derivative stuff. So we get a 2y. And normally if that were an x, we would just stop. But this is a y instead of an x, and we're finding the derivative with respect to x. So we are going to tack on this dy over dx. You can write y prime if you'd prefer that. I use dy over dx because then I'm less likely to confuse a y and a y prime. This is much more different. Then we find the derivative of this 2, which is going to be 0, and then find the derivative of x times y. That is going to require the use of a product rule. So we find the derivative of x, that's just 1, multiplied by that second thing, which is y, plus the derivative of that second thing, which is dy over dx. The derivative of y is dy over dx. And then we get this x. Now, what I've got here does not match up with what they gave us. What we need to do is, I would really like that y prime or dy over dx to be by itself. So I'm going to get those on the same side. So now I have this 2y dy over dx minus this one, dy over dx equals y. Then what I can do is I can factor out those dy over dx's. I missed an x earlier, so we get 2y minus x equals y. And then to get that dy over dx by itself, we would just divide by 2y minus x, and we end up with what they gave us to start with. So this dy over dx equals y over 2y minus x. In this example, I'm going to use the derivative we found in the previous problem. And we want to figure out all the points on the curve where the line tangent to the curve has a slope of 1/2. Well, if we want the line tangent to have a slope of 1/2, we want to set our derivative equal to 1/2. So we're going to say 1/2 equals this thingy thing up here, y over 2y minus x. Then we go to solve this thing. I'm going to do a little something horrible. I'm going to do a little cross multiplication. It is allowed in this problem. Be careful when you should use it. And then I want to try to solve this thing. Well, I've got those two y's on both sides. If I subtract them, I get 0 equals negative x. So that means x equals 0. So it seems that the only point where we have a curve, the slope of the curve is 1/2 is when x equals 0. But they want a coordinate point, xy. So we want to plug that x into our original function, because we want to know where it is on the original, not what's going on with its slope. So we're going to put that 0 in for our function. And then we get y squared equals 2. And so y equals plus or minus the square root of 2. So we do actually end up with 2 points, even though we only got 1 from our x value. The points are at 0 comma square root of 2 and 0 comma negative square root of 2. These are our 2 coordinate points where the slope of the curve is 1/2. Next, we're looking for, are there no horizontal tangent lines? So the horizontal tangent lines would be when our derivative equals 0. So 0 equals 2y minus x. Well, based on this, it just means that that is only going to happen when y equals 0. Okay, let's plug that back into our original function. So we get 0 squared equals 2 plus, 0x. So that means 0 equals 2. That is not possible. So there are no points on the curve because we got no solutions when we plugged in our derivative. Here's what I just said, typed out a little bit better. There are no horizontal tangent lines since the derivative is only equal to 0 when y equals 0. However, y is not part of the range of that function. Now, in this example, you can see a little bit more about what this implicit differentiation is used for. We're going to use our same y squared equals 2 plus xy, and we're going to be talking about what's going on at time t, but neither x nor y are representing time or t. So we are looking for what is dy over dt. We want to find the derivative of this thing with respect to t, instead of what we do a lot of times, finding the derivative with respect to x. So this y squared, when we find the derivative of that thing, just like before, we would get 2y, and then we would do implicit differentiation and we would get a dy, but we're looking to find the derivative with respect to t and not x. So then we find the derivative of 2, that is still 0. Then when we go to do this product rule and we find the derivative of x, the derivative of x with respect to x is 1. But the derivative of x with respect to t, a different variable, just like y gets all different, implicit and weird, the x does it as well. And we get this dx over dt. And then we leave y alone. And then when we do the rest of our product rule, I don't know why I changed colors. We get another dy over dt, finding the derivative of y with respect to t, multiplied by our first thing, which is x. So then we want to figure out what dx over dt is. We're looking for this thing. And we know that dy over dt equals 6. So we know that this is 6 and this is 6. And at time t equals 5, the value of y is 3. So we know that this y is 3 here and this y is 3 here. Now, the only thing I don't know is I don't know what x is. And they're trying to figure out what the value of dx over dt is. So I'm really curious what this x value is. If I can figure out that x value, I've got all my variables and I can solve for dx over dt. To do that, I can just plug it into her. So then we get 3 squared. Mel just kind of like came in like meowing about something. I don't know what she wants. Equals 2 plus, oh, she wants to play. She's playing with a plastic bag behind me now. I've completely forgot what I'm doing. 3x. And so that will be 9, 7, 7/3. Let's just copy in our stuff. So this is times 2 times that equals dx over dt plus these two being multiplied together. So now it's just a matter of simplification. And as weird as that might look, that's just a two-step equation that we have to solve. So we'd subtract our 14. So that would be 22 divided by 3. So dx over dt is just going to be, what did I just say, 22 thirds. In this example, we're just trying to figure out what dy over dx is going to be. So I need to find the derivative with respect to y. So that is going to be find the derivative with respect to x. Plus 3y squared. That's going to be normal, but it is a y, and I'm finding the derivative with respect to x. So we're going to get a dy over dx equals, then we're going to need to do a product rule on this. That 18 can go with the x or the y. I'm going to choose to do it with the x. think that might be a little bit simpler. Uh, and then our y is going to be our second thing. So derivative of our first is 18 multiplied by the second thing, y, plus the derivative of the second, which is dy over dx, multiplied by our first thing, which is going to be 18x. What we need to do now is we need to solve for that dy over dx. I'm going to subtract this 18 dy over dx, and then subtract this 3x squared. At this point, I can then factor out that dy over dx and then divide by the thing that's left over, that 3y squared minus 18. So dy over dx is going to equal 18y minus 3x squared over 3y squared minus 18. Now, if you're feeling fancy, you could cancel a 3 from all of that stuff. They might do that in like a sneaky kind of like multiple choice question. You can divide all those terms by 3 to make it 6y minus x squared over y squared minus 6. That is the end of our video on implicit differentiation. Reminder, it's just a problem where the x's and y's are mixed together. And then you want to treat that inside y function, use your chain rule, and create a dy over dx. These are functions where the x and the y are sort of mixed together and not explicitly said y equals something. Thanks for watching. Goodbye.